One particular series that we are most interested in is what's called a geometric series. And a geometric series is just a summation of numbers, and what you're doing from one number to the next number is multiplying by the same number every single time. And that number that you multiply, we're going to call R, is called your ratio or your common ratio. So for example, this is a series. A series just is an addition of numbers. And notice you are multiplying by 1/2 every single time to get to your next number. So this is a geometric ratio, a geometric series with a common ratio of 1/2. So first thing we want to be able to do is, given a geometric ratio, can I come up with the R value? So what number are we multiplying from here to here to get to the next number? Your R value is 2/3. Okay. This one, it's 7 plus 7, so you're just multiplying by 1 every single time. This one, you're multiplying by 2 every single time. And then this one, you are multiplying by a negative number, and it looks like it's negative 1/2 every single time. Now, what we are most interested in with these series is, does the series converge or diverge? What that means is, if I add up these numbers infinitely, is it going to approach a sum? Now, if you look at these numbers, notice they are getting smaller and smaller, so it looks like it's eventually going to approach some sum. So for right now, I'm going to say it looks like it's going to converge. This one here, if you just add up 7 infinitely, this is just going to get infinitely bigger. So it looks like there's not going to be a sum that this approaches, so I'm going to say this diverges. Okay? This one, notice the numbers are getting bigger and bigger, so if I add this up infinitely, there's no way this is going to actually approach one sum, so this would also diverge. And then notice here, looks like these numbers, it's alternating, but the numbers are getting smaller and smaller, so possibly it could converge. So this is what I have so far. So the general rule to tell whether a geometric series converges, it approaches a sum or not, is you look at this R value. The only way the numbers can get smaller, and when you add up these numbers infinitely to approach a sum, is if that R value is less than 1. If that R value is bigger than 1 or equal to 1, these numbers just get infinitely bigger. No way is this ever going to approach a particular sum. So that's the first thing. If that common ratio is greater or equal to 1, and it doesn't matter whether it's negative, the absolute value, then we say it diverges. If that common ratio is less than 1, then we say it converges, and the sum of that series is going to be A over 1 minus R, where A is going to be the first term in your series. So let's go ahead and look at a couple of these. Remember, your R value is whatever is being raised to the nth power, because it is what you are multiplying by every single time. So your R in this value is going to be 1/2. Your A in this problem is whatever the first term in this series is. So your first term is going to be when you plug in 4 for n, so 1/2 to the 4th is going to be 1/16. I notice that your R is 1/2, which is less than 1, so I do know that it converges, and if it converges, then there is a sum. Your sum is going to be A over 1 minus R. This simplifies down to 1/8. So that means if you add up all these numbers infinitely, so my first term we said was 1 over 2 to the 4th, plus 1 over 2 to the 5th, plus 1 over 2 to the 6th, and add this up infinitely, if you add those up, you're going to get to 1/8 as my sum. Okay. Let's look at B. Notice it looks exactly the same as A, and this is what's being raised to the nth power, so your R again is 1/2. But this time, your A is different. If I plug in 0 for n, your first term is actually going to be 1. So again, because your R is less than 1, it will converge. Your sum in this problem is 1 over 1 minus 1/2, and your sum is 2. And it should make sense that this sum is bigger than this one, because here you got a couple extra terms in the front, whereas this one starts at 4. Okay, let's jump down to D. Okay, notice here your R value is 3/2. Okay, your R is bigger than 1. These numbers are just getting bigger. There is never going to be a sum to this series, so we say it diverges. If it diverges, there is no sum, so you don't give me the sum. If it diverges, you're done.